to my channel and in coaching center. So today I'm going to explain your 12th standard physics 7th chapter, that is alternating current part 1 video. So let's come to the chapter. So introduction. So the currents do not change direction with time, but voltage and current that vary with the time and are very commonly known. And there are AC current that exhibits characteristics which are exploited in many devices of daily use. So they are used in many devices for the daily use. AC currents, as you all know. So AC voltage applied in resistor. So AC voltage applied in resistor. So in this figure 7.1, that shows that it has a resistor. This, or you can see here, this is the resistor connected to the source of voltage, source, that is this here you can see E, that is source of AC voltage. This is alternate current AC voltage, and the symbol of an AC source in a circuit diagram is like S. It is like S only, or we can say N. It is like that symbol. And also AC voltage be given by, it can be written as V is equal to Vm sin Wt, where Vm is the amplitude of the oscillating potential difference, and W is the frequency, angular frequency of this. So then we can put it as Vm sin Wt is equal to IR. So I is equal to Vm by R sin Wt. So therefore Im is equal to Vm by R is the formula we get. So Ohm's law, which for resistor works equally well for both. Ohm's law works for AC and DC, that is alternate current and direct current, both the Ohm's law works. And we see that the applied voltage, the current varies simultaneously and has corresponding positive and negative value during that cycle. Each cycle means during the every passage of current there will be vary in positive and negative. So thus the sum of the instantaneous current value over one complete cycle is 0. So the average value and instant current value after one circle, after one passage or one time of passage of current is become 0, and the average we get, we calculate also, it is also become 0. And it cannot mean that the average power consumed is 0. So we cannot say that the average power consumed by that is 0. So that there is a dissipation of electric energy. So there is a changes in electric energy. As you know, joule heating is given by T square R and depends on T square. It depends on T square whether it is positive or negative, and not on I. It does not depends on I. It depends on T square, like that only. There is a Joule's heating and dissipation of electric energy when an AC current passes through a resistor. There is a Joule's dissipation where when an current passes through an electric and AC. So the power displayed in the resistor is formula is P is equal to I square R is equal to IM whole square, R sin square YT, and totally we will get the P is equal to 1 by R T square M by R. To express the power of same form as DC power, P is equal to I square R also we can write a special value of current defined. It is a special value of current is defined and used, and that is called as root mean square is used for defining, or we call it as effective current, that is denoted by IMS or I. It is denoted the special root mean square that is used to denote the current, or that is used to say define the current. So next it is defined that I is equal to root I square is equal to root 1 by 2 I square M is equal to I M by root 2. So therefore this is equal to 0.707 I M. So this we get. And next in the term of I, if we take I, P is equal to P is, this formula we got there, no? So if we put that P is equal to 1 by 2 I square M, R is equal to I square R. Similarly we can define the RMS of voltage, that is the root here I said no, this RMS root mean square. of a voltage is equal to Vm by root 2 is equal to 0.707 Vm, and we have Vm is equal to Im square is the formula we get. So this is they have you given, and here also here you can use that formula to solve some problems. Next is representation of AC current and voltage by rotating its vector. So in this you can see that the current through a resistor is in phase with an AC voltage, alternate current voltage, and but this is not in the case of an inductor. In a case, this does not happen in a case of inductor, and a capacitor or a combination of these circuit elements. In order to show phase relation between voltage and current in an AC circuit, we have to use the notion of phasors. We have to use, and the vertical components of phasors are V and I represents the simultaneous varying quantity V and I that I represents, and the magnitudes of phasor V and I are respectively the amplitude of peak value Vm and Im. They are the amplitude of the peak value Vi and Vm and Im, and as the rotation with the frequency W curves in the figure 7.4 here. Here in 7.4 you can see the figure B. Here there is curve. As there is curve, we can see that V and I for the case of resistor are in the same direction. This is so for all times. That means that phase angle between the voltage and the current is 0. Here voltage and current phase angle is 0. It will become, because there is difference. See here, current is going like this, voltage is going like this. So, and AC voltage applied to an inductor. So here, see here, AC voltage is applied to an inductor. So inductor have appreciable resistance in their windings. So they have very much resistance. But we shall assume that the inductor has negligible resistance. We don't know how much it has. Let's assume. So let's take V minus L d1 by dt, di by dt is equal to 0. L is the self-inductive of the indicator. Here L you are seeing, no, this L, that is the self-inductive of the inductor. So let's take di by dt is equal to VL is equal to Vm by L. V by L is equal to Vm by L sin Wt. Let's take, and also we will put Vm by L, we will add to it, then di by dt is equal to Vm by L it will become, and therefore Vm by Wl is equal to cos Wt plus constant will get, and here we will put the cos Wt is equal to sin Wt minus pi by 2. So therefore when we solve whole thing, the amplitude of the current is, then we get is Im is equal to Vm by XL is the amplitude of the current. Thus we get it, and the SI unit of Ohm's law is here, as you all know. And the inductive reactive limits of the current are purely inductive, and here you can see we have to put pi by 2 or 1/4 1/4 cycle we have to put in, and it's a voltage of current passing. So next is phasor diagram of a circuit and graph of V and I versus Wt. So now T by 4 is equal to pi by 2 by W. Now P by L is equal to IV is equal to Im sin Wt minus pi by 2 into Vm sin Wt will put, and Im Vm cos Wt sin Wt. So Im Vm by 2 sin 2 Wt we will put, and PL is equal to Im Vm by 2 sin 2 Wt. So this we will do whole square and is equal to 0 will get. So therefore since the average of 2 Wt over a complete cycle is 0, the average power supplied to our indicator in one complete cycle also becomes 0. We have proved all the so this is a solenoid, as you know, in you may have learned in lower classes. So current through a coil entering at a increase from 0 to maximum value the current is entering, and flux lines are set up, i.e. set up, and the core gets magnetized, and with the polarity shown, voltage and current both are positive here both will be the positive, so the so the whole product here will be positive, and here the voltage and current are negative, so the whole thing will be negative. And here the voltage and currents are positive negative, but here the thing will be positive. And here in the 3.4 diagram, the voltage and current are positive, but whole thing will be negative. It will be become, as you know, minus plus into plus minus, like that you have learned in your max, no, like that only here also. And next is AC voltage applied to a capacitor. So here a capacitor diagram 7.8 you can see. So when a capacitor is connected to the voltage source in a so a direct current circuit they are first used direct current. So current will flow from a for a short time required to charge the capacitor. So current will flow for a short time, that time required to charge that capacitor plate. But that a capacitor in a DC circuit will limit or oppose the current as it charges. So after charge in DC current, direct current, if the capacitor gets whole charged, then it will oppose the current that come towards it, that then it oppose the current, and then the capacitor will become zero, falls in the zero. But the capacitor is connected to an AC source. When the capacitor is connected to alternate current source, so the limiter regulates the current, but it does not completely stop. So there will be limit, but the current will does not stop fully. It will not stop fully. There will be flow of current in that capacitor. So the instantaneous voltage V across the capacitor, V is equal to Q by C. So let's add Vm sin Wt is equal to Q by C. So d by dt is equal to Vmc sin Wt is equal to Wc Vm cos Wt. So by using the relation of cos Wt is equal to sin Wt plus by 2 that we got back. So I is equal to Im sin Wt plus by 2. So therefore Im is equal to Vm by 1 by Wc. Therefore Im is equal to Vm by Xc is the thing we get. So here the dimension of the, and again here they have given the Ohm's law, and the capacitor reactance limit the amplitude of the current is purely capacitive circuit in the same way as the resistance limits the current in a purely resistive circuit. So there will be limit, but in inversely proportional to the frequency and the capacitance. So there will be inversely proportional to the frequency and the capacitance. So here they have given a phasor is pi by 2. So here phasor is pi by 2, and the voltage phasor V as they rotate on counterclockwise like this, it will be rotating. In the diagram you can see like that. If it rotates, then the current with time, we see that the current reaches the maximum value earlier than the voltage by 1 by 4th of a period. So it will reach fastly 1 by 4th of a period than the voltage. So therefore P is equal to 1 m by Vm by 2 sin 2 Wt is the formula we get. So that the average power of them is Pc is equal to 1 m Vm by 2 sin 2 Wt is equal to 1 m Vm by 2 sin 2 Wt is equal to 0 is the average we get, and voltage is pi by 2, as you know. So this is the sum on that. So okay friends, here you understand I think so. So like the video, comment on my video, and subscribe my channel and my coaching center for more video, and share my video with your friends. So okay friends, I think you understand the topics, understand till here. So I will explain the next topic in my next video. So till then, take care, have a nice day, bye, see you my dear friends.